In section 1.7, we'll be talking about the intermediate value theorem. So first I want you to think about just this English word, intermediate. What does that mean outside of math? So hopefully when you think of that, you think of like middle or in between. And so what this theorem is about values that are in between other values and whether or not we have to reach them. So let's write out this theorem first and then we'll talk about it. So if, number one, f is continuous, on the closed interval a to b, and number two, k is a y value between f of a and f of b, then there exists at least one number c, x equals c, in the open interval a to b such that f of c equals k. So let's break down what that means. So first of all, when I have a theorem like this, number one and number two are called hypotheses. Those things have to be true in order for me to be able to apply this theorem. So one, f is continuous. Two, k is a value that's between f of a and f of b. If that's true, then there has to be a place where I actually reach that y value. So let's look at the graph and think about what this actually means. So I have my x endpoints, a and b, and I look at the y values of those endpoints, so f of a and f of b. What this theorem is saying is if I choose any y value in between those two, in this case it's just some point k, I have to hit that y value somewhere. So in this case I actually hit that y value 3 different times. What the theorem actually tells me is I just have to hit it at least once. So for example, if my y values are between 5 and 10 and I choose a y value 7, I would have to reach that at some point. But it's important that that value is between those two. So if my y values were 5 and 10 and I chose 12, I wouldn't necessarily have to hit 12. I could hit 12, but I don't have to. So it's important that my x values are between the x values of my endpoint and my y values are between the y values of my endpoints. So let's actually see if the intermediate value theorem, or we call it IVT, applies. And so the two things, remember, that have to be true in order for the theorem to apply is that your function has to be continuous and the y value you're looking for is between the y values of your endpoints. So question A asks, does the IVT guarantee a value of c such that f of c equals 2 on the interval -4 to 2? Why or why not? The first thing you always want to check is this continuous? So I'm looking from -4 to 2. And I could either look at the function or the graph. The graph is easier to see. This graph I can see is not continuous at -2. So automatically, if my graph is not continuous, then the intermediate value theorem is not guaranteed. So we're going to say, since f is not continuous at x equals -2, IVT does not apply on -4 to 2. Now that doesn't necessarily mean that there is no y value of 2 on this interval. It just means it's not guaranteed. If I look in this case, I can see there is no actual place where my graph hits the y value of 2. And that's because, again, this function is not continuous, so I can't use intermediate value theorem. For part B, I'm looking at the interval from -1 to 4. So from here, sorry, my line's not straight, to 4. If I look at that piece of the graph, I see it is continuous. So f is continuous. But the second thing I need to check are the endpoints. And so I can see my y value is about -0.5 at -1, and at 4 is -3. And so I'm looking at this y value of 2. Is 2 between -0.5 and -3, it is not. So again, IVT doesn't apply. So we can say, although f is continuous, on -1 to 4, 2 is not between f of -1, which is -0.5, and f of 4, which is -3. So IVT does not apply. And again, I can see on my graph, I don't actually reach a y value of 2 between -1 and 4. So in number 2, a lot of times you're going to see IVT on multiple choice like this, where it just has some arbitrary function. It tells me f is continuous on this interval. You're always going to be looking out for that. So if I see continuous, I underline it automatically. It kind of is a key to open up a lot of different theorems in calculus. We're on the interval -3 to 9. It tells me that f of -3 is 0 and f of 9 is -12. And it asks me which of these could be correct about the function f using intermediate value theorem. And so if I take a look at these values here, what I want to keep in mind is that my x values for this problem are between -3 and 9, and my y values are between 0 and -12. So I'm going to actually say y values between -12 and 0 just to go in order. So what IVT guarantees me is that I will hit every single y value between -12 and 0 when my x values are between -3 and 9. And that is again because my function is continuous. So A, it asks about f of 12, if that's equal to 0. My x value here is 12. That is not between -3 and 9, so it can't be that one. B, f of -1 equals -13. So -1 is between -3 and 9, but -13 is not between -12 and 0, so that can't be right. C, could f of -2 equal -10? -2 is between -3 and 9, and -10 is between -12 and 0. That seems like it could work. Let's check D just to make sure. 8 is between -3 and 9. 1 is not between -12 and 0, so D cannot be our answer. That tells us that C is our best choice. So where the intermediate value theorem is most often used in mathematics is to determine if a function has a 0 on a certain interval. It doesn't necessarily tell us where that 0 is, but just proves that we would have to have a 0 or an x-intercept. So in number 3, we're going to use the intermediate value theorem to show that f of x, which is x cubed plus 2x minus 1, has a 0 on the interval from 0 to 1. So the first thing I have to check automatically is my function continuous? So when I look at f of x, I know that's a polynomial, and polynomials are always continuous. So I'm going to say f of x is continuous on 0 to 1 since it's a polynomial. And really it's continuous for all real numbers. You could put that too. The second thing I want to check is 0. This is my y value. It's really asking me, does f of c equal 0 somewhere? I want to check to make sure that 0 is between f of 0 and f of 1. And so I'm just evaluating my x endpoints at my function. So f of 0 would be -1. F of 1 would be 1 plus 2 minus 1, which is 2. 0 is between -1 and 2. One of them is positive, one of them is negative, so I know I'm going to cross the x-axis. Again, I only know that because my function is continuous. So what I can say is, by IVT, f of c equals 0 for some c on the interval from 0 to 1, since 0 is between f of 0 and f of 1. So somewhere in there I need to talk about 0 being between f of 0 and f of 1. You could write an inequality for this, but I think it's actually easier to just say like the English word between. Sometimes you'll see it in a problem like number 4 with a table of values. And so we have functions f and g are continuous. Again, I'm going to underline that when I see it because that's going to be important to my problem. I have a table of values with f and g, and then I have this extra function h. This is a very common type of problem in AP Calculus where they give you a function that's composed of other functions. And it says, explain why there must be a value s for s between 1 and 7 such that h of s equals 1. When I see a function of a variable equals a number, I know it's not f in this case, but that general format, I automatically think IVT. Okay? And so to start out with IVT, I have to make sure my function is continuous. The function I'm talking about in this case, though, is h. And so I know that f and g are continuous. It doesn't tell me that h is continuous, so I'm going to need to state that. As if f and g are continuous, then the composition of those functions will be continuous. So I can say h of x is continuous since it's composed of the continuous functions f and g. So that's easy to like just know automatically, but I have to state that. If I don't state that, I'm going to lose all the points on this problem on the AP test. The second thing I want to check again are my endpoint values, h of 1 and h of 7. So I'm getting that just from this interval here. S is between 1 and 7. So I'm going to now use my equation for h. It was f of g plus 5. H of 1 then is f of g of 1 plus 5. When I'm evaluating this, I start at the middle. G of 1 is 10, so this is f of 10 plus 5, which is 2 plus 5, which is 7. H of 7 is f of g of 7 plus 5. G of 7 is 3, so f of 3 plus 5, which is negative 10 plus 5, which is negative 5. So the y value we're checking for is 1. We want to know, is 1 between 7 and negative 5? It is, which means I can use intermediate value theorem. So we can say, since 1 is between, and here, instead of just saying 7 and negative 5, I'm going to say h of 1 and h of 7, because I really want to connect it back to that function. Since 1 is between h of 1 and h of 7, then by IVT, and now for my conclusion statement, I'm just going to look back to the language that was actually used up here. Explain why there must be a value s for this interval such that h of s equals 1. And I'm just going to repeat that language. So then by IVT, there must be a value s for s between 1 and 7 such that h of s equals 1. So I'm just repeating that same exact language. So you're also going to see IVT sometimes on application problems. So number 5, it tells me water is leaking out of a broken pipe. The rate that water is leaking out is given by this continuous function. Again, continuous, that's important. Is there a time t for t between 3 and 6 such that L of t equals 15? So in other words, do I have to cross the y value of 15 somewhere between t equals 3, t equals 6? So I'm looking here between 3 and 6. Do I have to cross 15 there? So if I look between 3 and 4, 12.3 to 14.1, I don't necessarily need to cross 15. From 14.1 to 15.8, I would have to cross 15 as long as my function is continuous, which it told me up here. So I can say since L is continuous, and 15 is between L of 4 and L of 6. I could also say L of 3 and L of 6, that's true. Then by IVT, there must be a time t for t between 3 and 6, at which L of t equals 15. This last problem is how you're going to see IVT on Delta Math, and so I wanted to go over it specifically. It's going to be kind of a drop-down menu. It's not going to give you all this information at first, but some things to look out for. So in this problem, it tells me the function f is continuous on its domain from -9 to 9. So I see this graph, it's from -9 to 9. It is important that you look for this word continuous. If that word continuous is not there, you automatically cannot apply IVT. It tells me that f of 1 is -5, which I can see on the graph, and f of 6 is -3, which I can also see on the graph. Must there exist a value of c on the interval where f of c equals -4? So I'm going to check f is continuous because it tells me so. And then I'm checking, is -4 between -5 and -3? It is. And so I can say since -4 is between f of 1, which is -5, and f of 6, which is -3, then by IVT, and again, I'm going to repeat the language here, there must exist a value of c on the interval 1 to 6 such that f of c equals -4. So on Delta Math, you're going to have drop-down menus to like choose these options, but that in general is what it's going to look like.